Please welcome from Adobe, Frans Van Rooyen.
Hello? Can you guys hear me? Sounds like it. Good afternoon, you guys. Like I was just introduced, my name is Frans Van Rooyen. I'm an infrastructure architect for Adobe. I think most of you guys know who Adobe is, so don't really have to do an introduction on the company here, I hope. First off, I want to thank the organizers of this conference, CoreOS, for putting it on. It's been great. Beautiful venue, beautiful view. It's awesome to be here. Awesome to be sharing some time with you. I'd like to thank you guys for actually coming here and sitting down and listening to how we do stuff at Adobe, how we provision a multi-cloud platform at Adobe. Thank you for your time today. I'm excited to talk to you a little bit about how we do that. Is the timer going to go off here? OK. Just want to make sure, because I don't want to go over time. OK. There we go. OK. To get started, here's kind of the agenda that we're going to cover. First off, I'd like to talk a little bit about architecture. I think it's important to kind of talk about what the role is and kind of what we do from an architectural perspective. And then we'll kind of talk about the clouds. And I'm using clouds pretty loosely here, pretty liberal term, right? Kind of what it is a bunch of machines in a data center that we own or somebody else owns, and we do stuff with them, right? After we go through that and how do we actually provision in all of these different data centers the platform, I'm going to talk a little bit about what's next, what are we going to do next, what are we looking to, and what else you should know. Probably a lot, right? So, okay, so first off, the role of architecture. So I've been in this role for about 2 years now for Adobe, and it's been an interesting one. So I took the role of infrastructure architect, and the interesting thing behind it is that we learned a lot in the last 2 years. Architecture, a lot of people have views of architecture. A lot of people make jokes about architecture, and I've heard probably all of them, right? Maybe not, but there's probably some to come. But a lot of people view it as that, right? What we say, ivory tower architecture. Architecture sits in their ivory tower. They draw up their standards, they dictate what technologies you're going to use, and they throw it out there, and they're like, hey, oops, guys, good luck with this. I hope this runs well. See ya. And they're off, right? And they go off and work on some more standards. This doesn't work well, right? It just doesn't jive with the company, and it just doesn't work for teams. What we ended up doing, what happens if you take this role with our teams is they're like, yeah, right, we're not going to do this. We're just going to go off and do our own stuff anyway. So how do we resolve it? So something we started implementing and talking about is something else called lighthouse architecture. What is lighthouse architecture? Well, we go about with all of the teams. We see what kind of technologies they use. We talk to them about what are the problems they're trying to solve, and we go from team to team and see if there's any commonality between the problems that they're trying to solve as well as the technologies they use, right? So, and as we find that, we establish what we call guilds. So there's always that person, and I think you guys here are those people, are the ones that's very passionate about a certain technology. I'm passionate about certain technologies, right? Let's say this technology is unicorn service, right? I'm just all about unicorn service, and I absolutely love it. I go to every meetup that's about unicorn service, and it's awesome. And I'm going to go and promote it for my company and implement unicorn service. I get a lot of other people bought into unicorn service. That's awesome. Now we take that passion, we take those individuals that's about them, and we say, hey, why don't we form a guild? Why don't we get some of the other team members to come find out about this unicorn service and find out more how we can implement it? And soon enough, you have a community that builds out that's very excited about it. But what we've done is simply set the lighthouse in place. So as new teams are like, sweet, this unicorn service is awesome, they can be like, oh, but this other team already did it, and we can navigate around the rocks, and we can actually get it safely to production. Or unicorn service sucks, and it's a broken unicorn, and it's like, holy crap, that other team did it, and I'm not getting close to this unicorn service. Let's not get there. This is full of rocks, right? So kind of setting that up with more of a group mentality of where everybody gets to participate, everybody gets to voice their opinion, and forming not standards, but guidelines from there, right? So this is kind of the role of what we take from architecture. Work with a lot of different teams, see the technologies they use, so forth. Why is this important for my talk today? Well, you'll see a lot of choices we made as we went down to provisioning multi-cloud. And you'll be like, why are they using that tool? Just realize that tool wasn't me, Frans, saying, hey, thou shalt use that tool because I think it's really cool, or I know somebody that's written the tool. It's us all working together as a group that said, oh, this tool is going to work the best for us, okay? Going a little bit deeper, the role of an infrastructure architect. So when I was hired as this, I thought I'm going to do that, right? I'm going to go to the data centers. We have our own data centers. I'm going to go to the data centers. I'm going to go design rack designs, and I'm going to go talk about network architectures and network designs and look at routers and servers and do all this very physical hardware stuff. Instead, I'm doing that, right? I'm writing a lot of templates, and I'm involved in how do we deploy architecture to the clouds. Very much stuff that is software-based. Where do we store our templates? In what Yum repo do we put it, or in which Git repos do we put it in? How do we deploy it? How do we split it up? Things like that, right? So it's a very different role. It's a very different view of infrastructure architecture. And yes, I still do a little bit of the physical stuff, but more and more my life goes towards doing some of the stuff that's software-based. This isn't a bad thing, but it is a change. My favorite quote that I always like to go back to is one by Bruce Lee, right? Be like water. I think for all of technologists, not just architects, we need to kind of take this mentality. Our industry constantly change. We change, technology changes, and we need to be able to adapt, right? You might be loving working on a router. It's just as good working on a file that spins up a virtual router that gives you the same functionality. And in my opinion, it's pretty cool to write a file and see a whole system come up based on just a couple of templates. Okay, one of the other things we do with architecture is we as technologists really like technology, right? And like I said, unicorn, let's keep with that analogy, unicorn service, right? So when we go and visit the different sites and go down, about 2 days before I actually sit down with the teams, my calendar fills up. And I see demo 1, demo 2, demo 3, demo 4, demo 4. It's from 8 a.m. till 8 p.m. at night. It's just a bunch of demos, which is great. I don't mind working late, especially when you're out about, right, and interacting with the teams. However, it's all about technology, but not the problems they're solving. So it's like, Unicorn DB is awesome. You guys, we should implement this, and this is going to change the world. Well, what problem is it trying to solve? No, you don't get it. Everybody is doing it. Okay, but what is it going to solve for us? Well, I don't know. So one of the first things we ask is, why are we using this technology? What is the problem it's trying to solve? So when we're talking about platform, when we're talking about containers, when we're talking about multi-cloud, what is the problem we're trying to solve? And for you guys, I think you're actually pretty familiar with this problem, right? This is something that CoreOS messages very well, but let's just go through it. This is something we've realized as a company, and we're working hard on solving it. So it all actually goes back to the engineer. Right? We're a company that writes software, and it comes back to that engineer, that passionate engineer that sits down and says, hey, I have an idea, and I'm going to take that idea and turn it into a piece of code, a service, and then I'm going to earn the company a lot of money. It's that easy, right? Well, he sits down and he has his idea, which is great. We want him to have that, and this happens, right? It's just a bunch of processes, and he can't get out that code ever. Or by the time it finally gets done, it's stagnated, and it's changed, and there's a lot of problems with it. This is a big problem. We want to turn those ideas over to the revenue as fast as we can. This is the problem we're trying to solve, right? So deploying an app. How do we deploy an app? Well, if you deploy an app, you write that app on your machine. The engineer goes about and do it, pushes it into the repo, and then we deploy it into our different environments. QE gets it, demo gets it, dev gets it, pre-prod gets it, and then prod gets it. All of these environments are actually really, really, really hard to keep in sync, unless you do this, right? We have a container repo, and we abstract all of those environments to containers, right? And run an underlying platform that can run containers. That's the beauty behind containers, is we can wrap the code up and then ship it off independently and not care about the environment underneath. So we have a very unified way of moving code through. And this is a huge benefit and a big thing that we can solve, or a big problem that we can solve for the company. And this is why there's so much excitement, especially within Adobe, but I think across the industry for this. So if we flip the coin, operations says, oh, this is really cool too, because you solve the problem for engineer, but now I really don't care about how the hardware underneath looks either. I'm not going to get up at 2 a.m. in the morning and go troubleshoot some hardware in a data center because this server is specific to a certain role. All of the infrastructure becomes very generic. It becomes immutable, right? We just, if the server doesn't work, get rid of it, re-kick it, do whatever you do with it, but we don't care about the configuration on it. It's generalized, it's abstracted. If you think about my initial thing about infrastructure architecture, or my initial overview of infrastructure architecture, we've now abstracted away from the very hardware, the very touchy stuff, into the stuff that's very software and very immutable. So my title is Multi-Cloud Platform at Adobe. So why am I saying platform, right? The platform is actually where we can abstract away. So when we build it, here's kind of what's happening, right? We're going to go ahead and build the infrastructure into multi-clouds, okay? Then we're going to go ahead and level a platform onto there. And really, for compute, we're seeing that as an orchestrator, right? So we can say it's Kubernetes, we can say it's Mesos, we can say it's Swarm OS, we can say it is Unicorn orchestrator. It doesn't really matter. The function is the same. It provides a place for those containers to run in a scalable and a reliable manner, right? So all of these orchestrators, and we probably can debate those orchestrators for days on end, but in the end, that's what they're going to do for us. They're going to run our containers. They're going to enable that developer that's sitting there with his idea to deliver his idea into a Git repo. That Git repo is going to get built by Jenkins or another build system into a container and then delivered to a platform, right? And consumer, the one that's going to make us money, that's going to pay us money, is going to come in and consume that service. If you look carefully here, the developer nor the consumer had any direct access to the infrastructure, and they didn't care. They don't know what we're running underneath. We're running both in AWS, Azure, and private, but they don't care or they don't even know that. That's really down to operations to decide where this is happening, right? It's not the developer or the consumer here. The developer really just has to get his idea out. So that's why platform. Platform is a very powerful abstraction unit for us to away from the infrastructure and these multi-clouds. What we're going to do today is really focus on that part of it, right? The infrastructure part, and I'll tell you a little bit about how we provision that infrastructure at Adobe into these difference. Why multi-clouds? So we're multi-clouds. We are in multi-clouds, right? We are actually using two public clouds, Azure and AWS, and then we have our own data center. So it kind of drives the need. On a side tale, or a side story here, I'm a dad of not one boy, not two boys, but three boys, ranging from the age 10 to 3. Okay, that makes for a very, very busy life, an interesting life. Boys 10 to 3 can get into really interesting trouble, right? And they present really interesting challenges. We are not in one cloud, we're not in two clouds, we're not in three clouds, we're in three clouds, sorry. We are in three clouds. Three clouds present some really, really interesting problems. They're fun, they're interesting to work in, great people to work with, but they all present different challenges, just like my boy, 10-year-old, you know, he's getting kind of like, he's turning 11 soon, he's getting at that pouty age, I guess he's entering early teenagehood or whatever. He's getting kind of that pouty age where everything is just moaning about it, right? And the 3-year-old is just figuring out how to go potty, right? So very, very different problems that we're dealing with on those children. The same with the clouds. If you tackle them, don't think that one cloud is the same as the other. When you go into the data center's a little bit pouty, right? Oh, woe is me, public cloud is going to overtake us. You can probably figure out where the other two clouds go as far as children's age go. So, okay, let's tackle these clouds and see how we provision in them. The data center, okay. So how do we provision on our private cloud? Once again, like I talked a little bit about, bunch of service, how are we going to get through this? One, we're going to rack, cable, and power our gear, right? So we're going to take our gear. This is the basic stuff you have to do in a data center to get stuff going. I really liked the talk yesterday about do-it-yourself. Do-it-yourself is great, it's fun, but it's a lot of work. If you look at the steps in private cloud and you're going to see the steps in public, see how much fewer steps there's in public. They're both different, but there's both goodness about all of them. So, but it definitely takes a lot more to do it yourself. We have to rack, cable, and power. And how do we do that? There's tons of different opinions on how to rack, power, and cable your gear, right? So you can roll in racks, you can not roll in racks. You can buy converged infrastructure, you can't buy virtual infrastructure. There's a whole conference on open compute. Who here has actually been to the OCP summit? Okay, it's actually a really interesting, oh, great. It's actually a really interesting summit. It's talking about all about open compute, but more about hardware, like racking standards and developing rack as far as an open standard goes. That's pretty cool stuff, right? Facebook is a major contributor there. You find out about switches and the wedge and open switches and all of this stuff, right? But it's all about hardware. How do we at Adobe rack and power and cable our systems? We use robots, right? Like everybody. Who wouldn't everybody want to use those? Not really. I wish so. That would be really cool. Maybe the data center wouldn't be as pouty at that point. But we have an awesome staff. They work really hard. They're very peculiar in what they do. And every single cable is pulled just right. If I have to go into the data center and ever pull some cable, I think they'll throw me out because it won't be straight enough, right? Or it won't be the right color or not the right port or something like that. So, but really, this is you have staff that's doing these functions for you. Number two, you have to discover these systems. They're now booted, they're going. How do I discover? How do I know these systems are alive? I have to base the firmware. Who in here that's run their own hardware likes firmware management? Okay. I was really worried about asking that question because I wasn't sure if there's going to be somebody that's passionate about firmware management, like, you're crazy, firmware management is awesome. It's awful, right? It's the worst thing you can ever do. It never works well. You can never get the right version. And when you do, you soon get bit by it because then that version has some bug and all hell breaks out. But we have to decide on some kind of firmware version that we have to do. This is part of living in a data center. This is part of doing it yourself, right? Next, we have to provision the OS. We have to get some kind of OS on there. And you'll see I didn't name any tools because all of those three functions is actually taken care of by one tool for us, which is called RackHD. RackHD is an open source project, a great little utility. We call it LightIS. What it does is it's simply an HTTP server. Your system PXE boots to it. It goes ahead and says, hey, have I seen you before? So the discovery process, right? And once it says, OK, I haven't seen you before, run the default workflow. So RackHD has different workflows. Default workflow is going to go ahead and then put on that firmware that you dictated that system to have. So you're going to base the firmware. So it did all those functions for you. And then after that, if that system is discovered, you can say, hey, go ahead and now provision the system as this role. Therefore, it's going to go ahead and boot CoreOS into memory, right? So that's really the steps of what's going to happen in RackHD. So it's going to discover it. It's going to go ahead and firmware base it, and then get CoreOS loaded on it, right? It has task and workflows, and there's the GitHub project you can go to. There's other tools. It's not just RackHD. There was a great talk yesterday on CoreOS Matchbox. There's the link there. Kind of does the same thing, right? HTTP server, you PXE boot into it, you get CoreOS loaded memory, and you can move from there. Matchbox, the one thing is it doesn't do firmware management today. Like I said, nobody wants to do firmware management, and we need something to do it for us. RackHD does it, so this is great. And then, of course, there's the behemoth, which is OpenStack. It's saying, hey, instead of just doing a LightIS, why not build pure IS in your data center that you can then leverage your PaaS on top of? Well, I have some opinions there, obviously. I don't think right now to build a PaaS, you need an IS. This is something that we've actually gone through probably last year, not this year, but we went through it the last couple of years and tried to really decide what we need to do here. What we found out is OpenStack is just not a thing if you want to build PaaS. You can do it in a much simpler and faster way than having to install all of this. And I'm sure there's some of you that completely disagree with me, and I'd love to talk to you afterward about this. But from our opinion, and like I said earlier, from our broader opinion, not mine as architect, but from our guild opinion and the people that we've engaged with, this is really what we found out, right? OK, so at this point, think about where you're at. You have a bunch of machines that's racked and cabled beautifully. You have a tool that discovered them. They're now firmware-based, thank goodness. And there's CoreOS is running on top of them, right? Now, there's an interesting inflection point. I had a manager that used to talk about the spark of life. And he was a really interesting guy. I absolutely loved working for him because he always put out a challenge to us to do better and learn more, and very, very technical manager, and pretty much took our marketing cloud. He was one of the original members there and took it from a couple of servers to tens of thousands of servers, right? So huge respect for him. And he always talked about the spark of life. And what he meant there is when a server becomes more than that server, right? When we put in a machine, it's just a machine. It doesn't do anything. Like if you put on an OS, it's sitting there spinning idle with an OS. But there's this kind of change where it gets its services, it knows how to function, and you start hitting it, and it does all this stuff that it feels like it almost becomes alive, right? So how do we go from having the OS on there to getting that spark of life for the platform? And this is where Ignition comes in. Right, this is a CoreOS utility or a tool that CoreOS provides, and really does provide us in a very small tool, because if you look, it's a low system configuration utility, right? It doesn't sound like it does much, but neither does a Spark, right? One Spark doesn't do much, but look at what it can do for a rocket. It can set it off. That's really what Ignition does. It takes a very simple tool to build a whole platform, and that's what we use Ignition for, right? So it runs very early on boot. This is actually very important as we walk through this, because the earlier it runs, the more we can do. And if you look right there, that's exactly what it does. We can go ahead and partition disks. We can format partition. Here's the big one. We can write files, including systemd units. And so at this point, we're dropping in systemd units. It's actually setting up the platform. Just the configuration of the platform gets dropped in at that point. And it can set up network, which is great, without needing to reboot. Big thing on Ignition, it runs once, right? We don't want things to run multiple times. What happened with config.d, and we'll talk about it in a little bit here, is it would run over and over again. We wouldn't get it just right, and one service wouldn't be there, one service would be there, not sure on what the state of the system is. Ignition, we actually have a good idea of what the state of the system is, because it runs one and executes the file. It can find the file, it can find its source of truth from a URL, so from externally, or it can find its source of truth on the file locally as well. Okay? It uses a JSON configuration file, which is great, and it only runs once. Once again, that's kind of what I mentioned there. Oh, and then the other thing it has is no variable substitution. Why not? Well, it runs really early on. If you want to be able to make changes, do them like we do, which is just drop in systemd units after the fact. Get your system set up and then go ahead and do that. Here's an example. I know that's super small, I apologize, but what this actually does is it's actually setting up etcd, right? So you're actually dropping in 2 units there, and this is Ignition setting up etcd, really giving that system a spark of life and saying, hey, simple system, you're now an etcd node, right? It also does, the bottom part actually set up the metadata service, which then checks and sees, hey, is etcd service running? Oh, yes, it is, so I can go ahead and set it up. One of the things that we actually really like about Ignition, I don't know how many people like this, but if something fails, the whole thing just fails up and the server won't come up. So you never are in an unknown state. You're either working or you're not. That's actually really good when we're doing thousands of systems and we can see, oh, these failed, these are good. Because when they're good, they are good. They're not in some kind of unknown state. For the data center, this is kind of how we go ahead and do Ignition. We PXE boot, like I mentioned, from RackHD. And you have to, because on PXE actually skips, when you boot up through PXE, you actually are skipping grub, right? So you're going right into the system there. But then when you do your reboot, you have a kernel parameter was set called CoreOS.first equals boot. And then CoreOS will go ahead and run Ignition there. The example right there is just running a simple file right to the system. That simple function, that simple Spark, is actually what is building the whole platform. We're writing files that has full configuration for our platform, whether that be Kubernetes or whether that be DCOS or Swarm or whatever you want to do. Some other tools here. There's Cloud Config. Mentioned that a little bit earlier. Cloud Config and Cloud Init. Cloud Init is from Ubuntu. These does very similar things, but runs a lot later. And so you have multiple iterations of them to run. And so it's actually really hard to get stuff right. We've run through all of these. Ignition really did solve a lot of our problems. It's pretty solid. It's stable. It's a simple tool that does a lot for us, right? Since we're talking about a lot about do-it-yourself, are we done with the data center? No, not really, because if you think about the data center, There's more than just systems, right? There's more than just servers. There's a whole lot more. There's networking, there's storage, there's all power, all of these other stuff. RackHD actually does a good job of provisioning. Storage, we really don't see storage anymore as a SAN or anything like that. Storage is just compute with a software role of storage, right? However, networking is not quite there yet. Some great work being done in that space, though, right? How many here are familiar or have heard about SnapRoute? Oh, that's pretty good. Very cool. SnapRoute is a pretty cool company. If you guys could check them out, what they're doing is actually providing you the ability to hook your OS, your choice of OS, to the ASICs of the network switch, right? So now you can go use your same provisioning, your same monitoring, everything like that in the same system and be able to have a truly unified system throughout the data center, making the data center nodes, things like compute, storage, network, just that, software nodes. The hardware looks the same. You're just saying these are functional different roles. Facebook has an awesome paper out on CLOS architecture. When we're going towards this, right, if we're going towards container systems in the data center, we're having to think a lot about east-west. Suddenly that traffic picks up, so we're thinking a lot about that. And then my favorite quote there, because people come up and say, hey, what about, you guys are doing containers in the data center. What about container networking? Just going to go to Kelsey Hightower. Absolutely agree with him on this. There's no such thing as container networking. There's containers, there's networking. You can use networking to solve container issues, but there's no such thing as container networking. Okay, okay, that kind of wraps up the data center. So let's move on. Now, if you guys remember, there's quite a few steps on the data center. Let's look at AWS's steps, right? This is public cloud. There's no firmware, there's no racking, stacking, or any of that. That just doesn't exist. We're going in a software-only world here, right? We're going to write the template, we're going to go in and deploy the template, and then we're going to build the platform, okay? For us, the tool that we're actually using to write AWS platform templates for is called Troposphere. It's, once again, a very simple tool, but it does a great job because what it does is we can actually write the AWS infrastructure in Python, run Troposphere, and it's going to output the CloudFormation template for us on that. So we don't have to go write JSON ourselves. I'm not fond of writing JSON. I'd rather write in Python. Works a little bit better, and I get a little bit more functionality there. Simple to get Troposphere working. Just do a sudo pip install Troposphere, and you're ready to run. You can start writing your infrastructure there and transforming to CloudFormation. Okay? Other tools. Sure, you guys have heard about Terraform. This is an awesome tool. I actually really like it. It just didn't fit our needs. Once again, if you guys remember, architecture doesn't dictate. We kind of work with everybody, and this is the tool that just didn't work. But it's an awesome tool. Terraform supports multiple providers. So it doesn't just support AWS like Troposphere does. It supports AWS, Azure, OpenStack, some other clouds. And it actually has some interesting philosophy behind it. It actually splits out the planning and execution stage. What that means is you actually run what you call a Troposphere plan. So you go ahead, and what it's going to do is check your infrastructure and the changes that you made in the infrastructure with the running infrastructure out there and say, this is what's going to happen. And if you go ahead and do the commit, then that'll make that change. But it does split it up, so you have a chance to say, whoa, I didn't expect the load balancer to go away, right? Something like that. Or, of course, you can just go ahead and do CloudFormation. It's always there for AWS. It's their core tool. You can write JSON if that's what you're doing on a Saturday night. That's great. So go ahead and write CloudFormation JSON files. Next, provisioning AWS. Okay, deploying the templates. How do we deploy them? Fairly easy. You can use the UI, right? So you can go ahead and do the UI and just upload the template there. We use the AWS CLI at this point. Or you can even use Jenkins, which is pretty cool. This plugin from Jenkins, what it does is it's going to go ahead and load in the template, the CloudFormation template, execute it, and then do your build on top of the infrastructure that was just built, right? And then it can actually tear it all down. Developers, that's pretty cool stuff. So, okay. So now in AWS, if you think of where we're at, we've gone ahead and write our infrastructure up, right? We've submitted to some Git repo maybe. We've deployed the template from the Git repo, and it's provisioned and so forth, using one of those tools. In our case, it was Troposphere that provided the CloudFormation template. How do we build the platform? How do we get that spark of life in here? Here's where it becomes really cool, right? We're not now using yet another tool. We're using the same ignition data that we used for the data center. So the spark of life stays very much the same. And now we're seeing something interesting happening is that, oh, OK, we only have to worry about the underlying infrastructure. As soon as we hit this piece that we're actually building the platform, we can do it in a very consistent manner across the clouds, giving us a very consistent platform above the infrastructure, OK? Where do we inject this ignition data? We put it into the user data for cloud, the user data for the instance in AWS. The example I gave here is just a simple service, right? So, OK. That takes care of AWS. Next up is Azure. How many in here are actually using Azure today in production? OK, so a couple. Just another cloud, right? But like I said, has its own challenges, just like AWS or the data center does. OK, what did we do? We have 3 steps again, a little bit different than the AWS one. We fork the ACS templates, or we fork ACS, and I'll talk about that in a little bit and what that means. Then we go ahead and deploy the template, right? And then we go ahead and build the platform. And you should be guessing how we're building that platform by now. When I get there, it shouldn't be anything new. Okay. What is ACS? Azure Container Services. Okay. I think this is a great project. Azure actually open sourced it, which is pretty cool. The one thing there is people get ACS confused with ECS. ECS is AWS's version of Elastic Cloud, or Elastic Container Services. And pretty much the idea behind that is you submit your container and it runs as a service somewhere, right? Very much how AWS functions. That's not the case of ACS. ACS doesn't do it like that. What they do is they give you a set of templates that's already pre-built, and you can go ahead and run that against their cloud platform, okay? They built the container, they built those templates with their opinions, which is great because nobody understands Azure better than Azure. But you can go download and select your own orchestrator, which one you want to use, whether you can see those are the 3 supported, Kubernetes, DCOS, and Swarm, okay? And then also inject your own opinions in there. And that actually became really important for us to get that consistency, okay? If you want to learn more or see the GitHub project on ACS, there's the link. But what changes did we make? So we forked it. Here are some changes. One, we removed the VM image that was defaulted put into ACS. The VM image they actually were referring to build their platform was Ubuntu. We didn't want to use it because we want to use the ignition data later on, and we want to standardize on the, if you remember one of my original drawings, we want to standardize on CoreOS as the overlying OS in all the clouds. So that's one of the first things we did, okay? We modified the infrastructure. So this is, there's scaling sets, there is load balancing, there's routers, there's all of this stuff going on. So we kind of modified it to fit more with how we want it to be. We didn't want to just have 1 scaling set. We wanted to have 3 scaling sets when the platform comes up, right? So all of these specifications we actually made within that template. Here's a big deal. We removed the custom data segment. Their custom data segment would spin up, for example, DCOS. It would go ahead and spin up DCOS on top of Ubuntu using Cloud Init, right? We removed that, and then we replaced it with that ignition data. And then we added some security enhancements as well, right? We put in our own security rules. Adobe IP space was entered in, so only certain individuals can get to it, so forth, right? But this is actually really powerful because unlike with AWS, we had to go write the CloudFormation template from scratch, right? So we actually built that all from the ground up. Here, what we did is we got a template from Microsoft, kind of pre-built, made our changes to it, and now we can use it with all of the Microsoft goodness in there. So now how do we deploy it? You can do it through three ways as well. UI, so you can go into Portal, Azure Portal, and just go deploy it in there. It's fine. You can go do the Azure CLI. CLI is now in version 2, so it's actually AZ, is how you deploy it. And then I haven't tried this one, but I've seen a demo of it. You can deploy it through Visual Studio, right? So you can actually write your template in Visual Studio and deploy it through there. Don't know how that goes. I haven't tried it, but that is another way of deploying those templates. Okay, you guys should know what's coming, right? Building the platform is exactly the same thing. We're just using the same ignition data. However, Azure, there's a catch. you can put in a ton of data in their custom data field, right? So if we're wanting to build a whole platform, there's quite a bit of data that goes into there, standing up the Zookeeper clusters and the orchestrator and all of this stuff. There's quite a bit of information that needs to be in there. So what we do, and this is a neat feature from Ignition, is that we can actually reference external files. So all we need to put in is say, hey, this is the data you need to run through the custom data field, and then it's going to go ahead and override and pull in another config file that contains the whole thing. That's how we kind of get behind it. And that's actually a neat feature for Ignition. Some clouds just had limitation of how much data you can push into the custom data fields. OK. Cloud 4, I think up to now, I had like a question mark. Don't know if you thought it was GCE or Google, but it's not. It's actually Vagrant. And you're going to be like, Vagrant's in a cloud. It's just a product by HashiCorp. Well, one thing we did is, as we started working, we had to train our teams on orchestration and cloud or orchestration platforms and containerization and microservices. The best way we found to do this is actually have them stand up something on their own machine that they can start playing around with, right? And we found Vagrant to be a good tool. We actually stood up, like on their machines, we would stand up complete DCOS clusters, and they would go into the universe and launch packages and do etcd, and they can really get a feel for it, but it's on their own machine. So we don't have to spin it up in Azure, forget that it's there and pay a lot for it. We're not spinning it up on some servers that we forget that's there, and then servers get retired a lot later. It's just on their laptop. However, one of the things we found is that they started asking for this weird thing, offline mode. They're like, this is great, and I can develop against it, and I can actually test my containers out against this and all of this, but I want to do this on the plane. And we're like, well, OK. So the change we actually made is we took the original Vagrant files, we ripped out the default OS that it provisions with and changed it to CoreOS, and then we introduced the exact same Ignition data in there and got it to stand up. We also set up some additional functionality through Ignition, which introduces the core services, pieces that you need that's usually offline. Just a very minimal set of them, pieces like DNS, things like that. We introduced all of those pieces in there. And literally, when you stand up, you can be working on this thing on a plane, and you have a fully managed orchestrator on your machine. Depending on your machine's capacity, of course, it's either going to be really small. One of our guys has a 64 gig laptop, right? 64 gig RAM on his laptop, or really nice if you're him. But the point here is that we got the same system and the same pattern that we use in all of the clouds to work on one single machine. And the same Ignition data is running there. Now, that's pretty cool, right? The other thing we found with this is actually it turns out to be a lot more stable. Because Ignition does a run once and it runs so early, if for some reason Vagrant is actually, if you think about the environment, it's actually pretty dynamic, pretty chaotic. You're running on a machine. You're going to, oh crap, I have to leave for a meeting. Just close the machine, goes in sleep mode, or turns off. So these machines are constantly in flux. And when we switched it, when we ran it on CoreOS, when we ran it on Ignition, we actually saw that stabilize. Yes, it's not a production system. It doesn't really matter. But for a developer, not to have to go install the whole orchestration platform and wait yet another half an hour, and it's always there for him to just spin up, it's a pretty big deal. And so this actually was a really neat project, and some great work being done there. Okay, so the road ahead. I talked a little bit about the fact that we take the ACS template and we make some changes, right? We actually use Python to make those changes. And today, it's pretty simplistic. It's just a bunch of string manipulations that we do. However, we've had now the teams coming saying, no, this isn't enough. You guys need to do a lot more with this. We want a templating engine. So we can do some advanced changes on those templates. So we're starting to look into a templating engine. Jinja is one of them. Mustache is another. Looking at a couple of templating engines and what we'll use there. Another one is we need to secure our Ignition data, and we're thinking about securing it with Vault. Right now, it's just coming in clear text. And then the last one is something we call MCT, and this is actually a much bigger and larger project. MCT for us stands for multi-cloud transport. I've talked a lot up to now about like building all of these pieces out in the cloud. If you think about it, all I've really said is we're standing up platforms or clusters in the cloud, and they're all individual, right? There's AWS, there's Azure, there's our data center. I haven't talked about interconnectivity, though, right? So if one cluster wants to get to another cluster, how does it happen? Well, does it have to go over the public internet? Do I have to have a load balancers, all of this stuff? This particular project actually is what we're doing to simplify all of that. Literally, if you're spinning up a container in Cloud A, in some region, let's say West Coast, you're spinning up that container, it will be able to talk to a container in Singapore in Cloud C without having to transit public cloud, right? Also, the other thing is it simplifies the way we actually manage our IPs. So this is what we call MCT, multi-cloud transport. Okay, some final thoughts. This is a great, CoreOS forms a unifying layer for us to provision between clouds. You could see, hopefully you could see where we used Ignition, how we were able to use that platform to be able to do cloud abstraction. I said time for demos. We have 30 seconds left, so I don't think that's going to happen. I'll post some of the information I have on the demos, and I'll post the deck. Since we don't have any time left, please feel free to tweet me or just find me after. I'll be happy to answer any questions. Thank you so much, you guys. Wonderful area, wonderful crowd. Thank you so much, and have a good day.